As we go into part 2 of what we have here, we're going to take a look at what is called the discriminant. Now, here we see the quadratic formula, and what I've outlined in red here, under the radical sign, what does this do? Well, let's just take a little bit of background on this here. Well, we said if this, under the radical sign here, this in red, turned out to be negative, that is -1 and more larger negatives, these were going to end up being imaginary parts that led to complex numbers. Now, if under the radical sign, this discriminant, b squared minus 4ac, was a 0, then instead of getting 2 possible answers, as you got here, you would only get 1, because plus or minus 0 made no difference. This just gave you 1 real number answer. And we also said that if you had values that were greater than 0, under the radical sign, then you would get 2 real number values. Now, in some cases, they would be irrational if this wasn't a perfect square, or if this were a perfect square, they would be rational values. So, just what you have under the radical sign, which is called the discriminant, determines the kinds of solutions you're going to get. And this is the background of what we're looking for. So when we do example A here, it's in standard form. What do we need from this? Well, we're just asked to find the discriminant. So we're going to go b squared. Now, b squared would be 11 squared here, minus 4, a is 3, and c is -7. So we're going to multiply that through. Now, an interesting thing to note, if your c term is negative, because this 4 is negative, this will end up being positive. So you know it's not going to be an imaginary number over here. And when we square the 11, we get 121, and we get a total of 205. So this is not a perfect square. So over here, you're going to get 2 real but irrational values as answers from this quadratic equation. All right, well, let's go on and see what they have for us. They've identified the A, B, and C. They substituted, and they get this. So there are 2 real solutions, and we also knew they were going to be irrational, because that's not a perfect square. Okay. Now, just looking at this, notice your C term is a +9. Your B term that you're going to square is only 36. I can see what's going to happen here. This is going to be a positive 36. So let's just look at this one. We've identified our A, B, and C. we've substituted, and when we put it in there, 36 minus 36, that's a 0. So you're going to have the square root of 0, which is a perfect square in a sense, which is 0. So you're only going to get one real number solution. And in fact, if you remember, this was a perfect square trinomial, and where we get two answers, both of them are the same. So, there is only one real solution, and it's actually used twice, but one solution. And that's not the answer, by the way. This is just the result of finding the discriminant and then determining the number and kinds of answers you're going to get. So, that's what that is. Okay, now for this one, you might say there is no b. Well, yes, there is a b, but the b is a 0. So, and our c term is a positive. So we're going to square 0 and get 0, and then we're going to go negative 4 times 1 times 1 is going to give us a negative 4. So under the radical sign, let's just look at it. It's probably easier this way. So under the radical sign, you're getting a negative 4. So there are two non-real solutions. That is, complex numbers. Again, well, actually, in this case, it's b is 0, and alright. This happens to be the answer also, but that's another story. Okay, now what they're asking us to do here, this gets to be a little challenging. It says, determine the values for C such that this will have one real number solution. So here you don't know what C is, but you want it to have one real number solution. Now as I look at this, I can see that if we made this into a perfect square trinomial, we would have our C value that would just give you one solution. But they're also giving us a hint here. Set the discriminant equal to 0 and then solve the equation. So what did we say the discriminant was? Let's do some writing here as we brainstorm. Well, we said the discriminant was b squared minus 4ac, and they're giving us this hint of equaling it to 0. So b is 8, so this is going to be 64, minus 4, and we know that a is 1, so that's going to equal, and then there's a c here, and that's going to equal 0. So we can bring this negative 4c over to this side and get 4c. And this is 64. So we divide both sides by 4. C equals 16. Ah. Now let's just follow what I had said here too. that if this were going to be a perfect square here, we're going to do this from completing the square. You know what x goes here. Half of this is 4. Squaring this gives us the 16. So that's another way to figure it out. I don't know if they're going to show us this way. This is what they're suggesting. There's what they suggested. And they get 16. Okay. And if we put 16 in there, this is a perfect square trinomial that if we factor it, we get x equals -4. But there's only one solution. Thus, -4 is a double root. Okay, here they're asking us to determine the value or values for a such that this will have two non-real solutions. And then here, set the discriminant less than 0, and then solve for a. All right, let's set that up. So there's our discriminant, and we're saying that this is going to be less than 0. If you recall our first slide, in order for this to be non-real solutions, that is, complex numbers, imaginary numbers, what we had under the radical sign had to be less than 0, that is, negative. So let's follow this through. So we know that our b value is -8 that we're going to square. And then this is going to be a -16a. And we're going to put this on the other side. Or if we put the 64 on the other side, when we divide by the -16, we're going to have to reverse that inequality sign. So let's see what they're going to do. All right, they're going to keep it this way. They're going to transpose the 64. Now you're going to divide both sides by a -16. When you do that, you have to reverse the inequality sign. There you go. And you get a has to be greater than 4. If a over here, this a here is greater than 4, this will end up being negative and will give you two non-real solutions. So here they're pushing that bar somewhat up there, so we're getting some challenging things, but hopefully they're making sense. Okay, so this wasn't too long. Here are some practice items. And you might say, what would you do here in number 4? Well, you would multiply each term by 4 to get rid of these fractions. And here, for number 6, one of the things we just finished, you want this to be, the discriminant here to be equal to 0. And again, you could also use completing the square here. We have a little bit of time. Let's just take a quick look at that. It'll be a nice review. So this is going to be an x. This is going to be a -3. So our c will be a 9. When we square the -3, this gives us a 9. So our c here will be a 9. When it's in, now that's not the answer, but when we do it, we're going to find that if we put a 9 where the c is, then we get one real solution. But that's not the question now. I should have read it more carefully. All right, let me pause here. So I had to modify that. If we wanted just one solution, it would be c equals 9. But we want it to be greater than 0, so they are real solutions. So we just have to change this to c is greater and take away the equal part here. And I should read the problem a little more clearly and carefully here, what they wanted. If they just want one solution, we could have completed the square and gotten the 9. But we want it to be greater than 0, so we get two real solutions. So it's c is greater than 9. Okay, well, we don't want to make this too long here. So those are that, and let's look at the solutions. There we go. C is greater than 9. Okay, well, we have 2 more lessons left in this part in Chapter 12. So we're moving along, and we'll pick up on the next one shortly.